Hi, my name is Mikhail Axman,
And my name is Dylan DeVore.
and we're going to answer the burning question that you all have wondered the answer to forever. What's a voltaic cell? A voltaic cell was discovered in 1793. Alessandro Volta discovered that electricity could be produced by placing different metals on the opposite sides of a wet paper or cloth. He made his first battery by placing silver and zinc on the opposite sides of a moistened cloth with salt or weak acid solution. Therefore, these batteries got the name voltaic cell. Voltaic or galvanic cells are electrochemical, which contain a spontaneous reaction and always have a positive voltage. The electrical energy released during the reaction can be used to do work. A voltaic cell consists of two compartments called half cells. The electrons in voltaic cells flow from the negative electrode to the positive electrode, or anode to cathode.
Electrochemistry is the study of electricity and how it relates to chemical reactions. In electrochemistry, electricity can be generated by movements of electrons from one element to another in a reaction known as a redox reaction or oxidation-reduction reaction. This is exactly what happens in a battery. We've decided to show you step by step how to build a battery so you can better understand electrochemistry and voltaic cells.
Here you can see a battery setup. There's a lot you have to take into consideration and understand before you begin to set up the battery. We sketched out our ideas in this picture of our design you see to better understand the concepts.
The first thing you have to determine is which is the anode and which is the cathode. The activity series helps you to determine which metal is the cathode and which is the anode. You refer to it, and whichever is higher up on it is more reactive, or the anode.
To understand the anode and the cathode, you must first understand the definition of electrode. An electrode is a piece of conducting metal in an electrochemical cell in which either oxidation or reduction takes place.
An anode is the electrode at which oxidation occurs, also known as the half cell, where oxidation occurs. In our battery, it was the lead. The cathode is the electrode at which reduction occurs, also known as the half cell, where reduction occurs. In our battery, it was copper.
Here you can see a picture of the anode beaker, which contains an ionic compound. The anode in our battery was lead, so the ionic compound was composed of lead and sulfate. The purpose of the lead in the ionic compound is to help oxidize or reduce the anode and cathode. The anode is oxidized, which means it loses electrons or becomes more positive. Lead goes from a 0 to a 2+ charge.
Oxidation is the loss of electrons or an increase in oxidation state by a molecule, atom, or ion.
The cathode beaker shown in this picture is the one that contains the metal that becomes reduced.
Reduction is the gain of electrons or a decrease in oxidation state by a molecule, atom, or ion. The anode is the metal that is oxidized or loses electrons. In our battery, it was the lead. The cathode is the metal reduced, which gains electrons. In our battery, this was copper.
The oxidation number is the charge an atom would have if electrons were transferred completely. Electrons are being transferred constantly throughout the battery. Electrons flow from anode to cathode in a battery or voltaic cell.
Here is a picture of the anode and the cathode, which are both metals, before we place them into the solution.
The oxidation equation is when an element loses electrons after it goes through a chemical change and becomes a product. The equation for anode that's oxidized was Pb to the second, which is aqueous, plus 2 electrons equals Pb, which is solid. For the cathode, which becomes reduced, the equation was Cu to the second, which is aqueous, plus 2 electrons, which equals Cu solid, also known as the reduction equation. These equations are clear representations of the metals being either oxidized or reduced, as you can see the electrons being added or taken away.
The oxidation agent is a species that accepts electrons. In our battery, it is the cathode, which is copper. It is considered this because the electrons flow through the battery from the anode to the cathode, so the cathode is one accepting the electrons.
The reduction agent is a species that donates electrons. In our battery, it was the anode, which is lead, because the cathode starts the movement of electrons.
Here's a picture of the setup continuing. You can now see the two 250 milliliter beakers full of ionic compounds with the anode and the cathode submerged in each one.
The anode, which again is lead, is submerged into an ionic compound solution which contains lead as well. The electrons in this compound help the anode to oxidize. The metal is lead, which is negative because it's the anode. It has a charge of 0 because it is neutralized by the positive potassium, which is from the KCl found in the salt bridge. The lead with the positive 2 charge are donated from the ionic compound solution to oxidize the anode. The anions in the solution move away from the anode.
The cathode, which is copper, is submerged into an ionic compound as well as that contains copper. The cathode that has a positive charge but becomes neutralized by the negative chlorine from the KCl found in the salt bridge. The copper with a positive 2 charge from the solution donates its electrons so that the cathode can reduce or gain electrons. The cations in the solution move toward the cathode.
What happens in the anode and cathode separately is known as the half reaction. The half reaction is the separate oxidation and reduction reactions that occur in the anode and cathode, which make up the whole working battery, which is a redox reaction.
You may have also noticed the piece of filter paper that is being used to connect the two beakers together. This is known as a salt bridge.
The salt bridge in a battery is a piece of filter paper dipped in KCl solution. The salt bridge allows for net charge neutrality by transferring ionic charges to allow the system to remain charge balanced. The potassium is positively charged, and that goes to the anode because it's negative. The chlorine is negatively charged, and that goes to the cathode because it's positive. This helps to keep the neutral idea of a voltaic cell.
The salt bridge is also known as an electrolyte. An electrolyte is a substance that ionizes when dissolved in a suitable ionizing solvent. In our battery, it was the salt bridge because it allows for the flow of electrical charge between the anode and the cathode.
The spectator ions also can be found within the salt bridge. They are the ions of KCl. Spectator ions are the ones that are unchanged between the reactants and the products. The job of the KCl ions is to neutralize the anode and the cathode with their charge. They don't lose or gain electrons, so therefore they are not changed.
You can also see in this picture the Pasco voltage probes and the alligator clips that are used to attach them to the anode and the cathode. This is how we tested our voltage.
The voltage meter was the Pasco voltage probes and the computer that had probes attached to it. You had to touch the blue probe to the blue probe from each device and the red one to the red one from each one. When you did this, the voltage was read on the computer and it was 0.47 volts. We predicted this before by looking at the table in our book. We looked at the lead and the copper in the table and then subtracted them from each other in order to predict the voltage.
You are able to get an accurate reading of your voltage as the electrons flow around in a circle from the anode to the cathode. As this continues to happen, the anode corrodes because it is giving electrons, and the solution it's in gets lighter because it is giving the electrons as well. The cathode builds up the solution, and it becomes darker because it is accepting the electrons.
The battery will eventually stop working when one of many things happens. If the KCl and the salt bridge were to run out, then the battery would stop working because the ions from both of those would not be able to neutralize the anode and cathode. Or if the solutions ran out, the battery would stop working because they are donating the electrons necessary to oxidize and reduce the anode and cathode, which keeps the flow of electrons going. When the flow of electrons stops, so does the battery.
We hope that by watching our video you have learned the answer to what is a voltaic cell and are able to better understand electrochemistry through the process of building a battery. Thanks for watching. If you would like to learn more, please continue watching as we have included information and a few topics related to batteries. Also, check out our works cited.